So what we're going to use to look at why solids, liquids, and gases have these different properties is a model from this website here. And remember, we talked a little bit about models already, about how, remember we talked about atoms, how we have models of atoms. Why do we use models to help us understand atoms? Does anybody remember? Why do we use a model? I got the same 5 folks answering all the questions. Oh. Yes, in the case of an atom, they're so small, we can't really see them. No one's ever directly looked at an atom. So a model helps us to understand how it looks. So we're going to do the same thing here. One of the biggest reasons that solids, liquids, and gases have the properties that they do is at their particles. Now, we know that all matter is made up of tiny particles. What are those particles called? What are those tiny pieces that all matter is made out of called? What are those tiny pieces of matter called? The tiniest piece of matter you could have, what are they called? Atoms, yes. And then the atoms, when it's different elements, they join together to make a compound. So we're talking about the smallest piece of the compound here, molecules. And so what we're going to do is look at the particles of solids, liquids, and gases. Now, notice how we've got this beaker here, and there's something in it. Can you tell whether it's a solid, liquid, or gas? What is it? A solid. How do you know it's a solid? What tipped you off that this is a solid in this beaker? What tipped you off that it's a solid? How did you know it's a solid? Emma, how do you know it's a solid? Yes, it's held together. And what else? Braden. It has its own shape, doesn't it? So right away, if I see something that's got its own held together with its own shape, I know it's a solid. So the way this website works is I'm going to click on solid, and then what it's going to do is going to show us how the particles in a solid look. Now, I don't know what this particular solid is supposed to be. It looks like an amethyst to me. Have you ever seen that purple quartz, the amethyst? And what they're going to do, you can see in this big round circle, they're pretending like this is some sort of microscope that lets you see how the particles are behaving. What I want you to do is look at the particles in the solid and tell me what you notice about them. There are 2 or 3 things you'll notice right away. So I'm going to click on solid. Tell me one thing you notice about how the particles are. So we're looking at the molecules of this solid. What do you notice, McKenna? Yeah, they're all packed in pretty tightly, aren't they? They're squeezed in there. There's not much space in between them, is there? What else do you notice? Neela? Yeah, they're moving. They are moving. Can you see how they're moving a little bit? Now, let me ask you this. Are they moving all around? No, they're sort of like shaking or vibrating in place, aren't they? But they are moving. Anything else you notice about them? Mallory? Yeah, there are. They're packed in there so tightly. They're squeezed in. Anything else you notice, Landry? They are. Yeah, and that's because they're all the same material there. It's all this. I guess it's an amethyst. I guess pretend like it is. I don't know what it is. Yeah, so it's all the same type of molecule. What about how they're arranged, how the particles are laid out? What about how they're laid out, Tyler?
They're in nice, neat rows.
They are in nice, neat rows, yes. And if you look right here, you can see they're in a pattern, aren't they? One of the things about a solid is that the particles of them are locked together in a fixed pattern. Now, the pattern that they're locked in depends on what the solid is made out of, okay? So you can see that they kind of remind me of soldiers. They're like all lined up nice and perfectly, like, you know, how soldiers would line up. So the things we noticed about a solid is that they're packed in tightly. They're moving, but are they moving around? No. And they're in an organized pattern. Now, what I want you to do is, I want you to draw the sample in the beaker. I'm going to walk around and let you see somebody's from last year, how they did it. You're going to draw the sample in the beaker and then draw this pop out where they're looking in the magnifying. As I'm walking around, you can see, looking at the magnification of it. You see how she drew? So you can draw the solid in the beaker and then draw that magnified view of the particles. Now, when you draw the particles, you need to draw them packed in really tight. Nice and organized to get this one solid. And then also label that this was a solid. She drew that solid. And then she drew the magnified view of it. So draw that. That's what I want you to draw. And make sure you label that it's a solid. So you're basically drawing this beaker with the solid in it, and then this magnified view.
I'm sorry.
Now, I'm getting ready to turn this to a liquid. And we're going to look at the particles in a liquid. What do I need to do to this solid to turn it to a liquid? What do I need to do? What do I need to do? Raise hands, please. What do I need to do to get it to turn to a liquid? Cameron. Yes, I need to heat it up. So notice that when I click on liquid here, watch what this temperature gauge does. And you need to look at how the particles of a liquid are different than from a solid. Now, this is sort of a lower budget animation. Either they didn't have a lot of money to spend on it, or, you know, it's an older one. And I think it is pretty old. So there are some limitations to this, but tell me what you notice when I heat this solid up and turn it to liquid. Tell me how the differences are in the particles. So I'm applying heat. So tell me one thing that you notice about the particles of the liquid. Bryson? Yes, before they were just vibrating in place. Now their motion's different. They're sliding all around now. What else do you notice? Brian? They are loose, aren't they? Are they in that pattern anymore? No, pattern's out the window. No more pattern. They're not walked into that formation anymore. What else? Mallory? Yeah, now that Mallory's pointed out the thing that I don't think they intended to do. I think it's because this is an older animation. See how these ones on this top layer are acting? They would all be acting that way, behaving that way. So all the particles in a liquid slide around. They're not in any kind of formation. Are they as tight as they were? Now, there's some bigger gaps between them now. They're still packed in pretty tight, but not like they were as a solid. What about their speed? McKaylee? They are moving faster. Okay? So the things we've noticed, no formation, spread out a little bit more. They're moving faster. Okay? And they're sliding all around now. Draw the liquid in the beaker, and then draw the pop out for the magnification now. So when we look right here at the way the particles behave in a liquid, one of the things that should start to come to mind is the differences between a solid and liquid. Solids have a shape. Liquids do not have their own shape. Think about how the particles are in a solid versus how they are in a liquid. Can you figure out why liquids don't have a shape, but particles do, now that you've seen how the particles are acting? Talk to your neighbor first.